All right, so looking at this as you were writing it down, obviously you had to read it to write it down. Doesn't mean you completely understood what you're going to end up doing. But step 1 should look, excuse me, very familiar. When did we go over what is in step 1? We did all of step 1 already. When did we discuss what is in step 1? If you're not sure, it's on the agenda or your notebook. Mateo?
Yesterday or Monday? Tuesday.
Tuesday. Perfect. Yes. So on Tuesday, we went over factor trees and prime factorization. Okay. So we're using what we used on Tuesday to now find greatest common factor. All right. Greatest common factor is something you were taught in 4th and 5th grade. Typically not taught with factor trees and prime factorization. Okay. Because obviously they're just introducing it. Okay. So what we're going to look at today with factor trees and prime factorization is honestly a much quicker and much easier way to find greatest common factor, and then on Tuesday, least common multiple. Okay, and I will show you, we will do several examples this way with factor trees and prime factorization. And then we will do one probably the way you were taught in 4th and 5th grades, just so you can see how much quicker it is to use factor trees and prime factorization to find greatest common factor, and then on Tuesday, least common multiple. Okay, so first thing we're going to do is make a factor tree and write the prime factorization for each number. Okay, that's what we did on Tuesday. This is why we need to remember those first few prime numbers. Again, what are our first few prime numbers? This was on Tuesday also. Mason, what's a couple?
2 and 3.
2 and 3? What else? What would come next? We only need to know the first few off the top of our head. Mateo, 2, 3, 5. What else? Jordan?
19.
It is 1. You won't use that as much on factor trees. Doesn't mean you might. Mateo? 7. And then like 11. Okay? We need to be able to recognize those first few prime numbers. I will never expect you to know all the prime numbers from 1 to 100. Okay? You have a chart that you can look at if you need to, or you have Google. But knowing the first few is definitely something you need to know. Then, once we make our factor tree to write our prime factorization, we are going to multiply the numbers that are both in both of the prime factorization lists. Okay, and that'll make complete sense as we do our examples, which is why it is so important that you write down examples. Okay, so first one we're going to do is find the greatest common factor for 12 and 66. So we're going to go back to what we did on Tuesday. We're going to make a factor tree for 12 and a factor tree for 66. Now remember from Tuesday, you may start your factor tree different than the person sitting next to you. But the nice thing about factor trees, if you're using numbers that actually multiply together to get the number, your prime factorization always ends up the same. So, what is...
the interruption, students, staff, there are still about 200 students who have not selected a voice and choice for next week. Please get this done within the next half hour, 45 minutes, or the guidance office will start scheduling for you. Thank you.
So you'll have to wait. We got plenty of time if you didn't do it yet. What are two numbers that we can multiply to get 12? Mateo? 6 and 2. Okay? You could have used 3 and 4. It doesn't matter. You will still end up with the same prime factorization. Are either of those numbers prime? Mateo? 2. So we're going to circle it. 6 is not prime, so we have to break it up. What can we multiply to get 6? And we don't use 1 because remember, 1 is not prime or composite. Leah? 2 and 3. Okay, and again, this is where we need to recognize 2 is prime, 3 is prime. Nice and quick and easy. So then my prime factorization for 12 is 2 times 2 times 3. I take all those prime numbers and write them as a multiplication problem. 66, what can I multiply to get that? Again, there's many different things, and it doesn't matter where we start as long as it gives us 66. Jordan? That's what I would do because that just seems to come easy to my head. Okay? Either of those prime. Leah? 11. You could have done 2 and 33. Okay? 6 is not prime. If you're not sure what it was, you can look at your other factor tree. A lot of this stuff will keep coming up. So if we look over at our 12, we know that 6 was 2 and 3, and those were both prime. So your prime factorization for 66 would be 2 times 3 times 11. That is what we did on Tuesday. So now to find greatest common factor, you're looking for numbers that are the same, except I wrote one thing wrong. That second number is supposed to be a 3. 2 times 3 times 11. So you're looking for numbers in both lists that are the same. So we have a 2 in both lists, and we have a 3 in both lists. So then our greatest common factor is just what we get when we multiply those two numbers together. So your greatest common factor would be 6. You got 2 in both lists, a 3 in both lists, and you multiply them together to get a greatest common factor of 6. Jordan? Of 12 and 66. So of 12 and 66, the greatest common factor is 6. Okay? We're going to do another one like this before I show you a comparison between this method and probably the method you were taught in elementary school. Okay? All right. We are going to find the greatest common factor for 32 and 48. So we're looking for the biggest number that can divide into both of those. Now, one thing when I always made factor trees, I always paid attention to this last number. If the last number is even, what do we know will go into it? Always. If the last number is even, what do we always know will divide into it? Mateo? 2. So if you can never think of anything else that might go into 32, since the last number is even, we know 2 will. Okay? But it could be anything. So what can we multiply to get 32? You don't have to use 2. Leah?
4 and 8.
4 and 8. You can do 2 and 16. Okay, there's many options, but you will still end up with the same prime factorization. Neither of those are prime. So we've got to break them both up. 4, you can take 2 times 2. Those are prime, so we're going to circle them. What can we multiply to get 8? You just can't use 1 because it's not prime or composite. Leah?
4 times 2.
2 and 4 again. 2 is prime, so we can circle it. 4 is not, so we have to break it up. And what can we multiply to get 4, but not 1? John? 2 and 2. Perfect. So our prime factorization for 32 is 2 times itself 5 times. So 2 times 2 times 2 times 2 times 2. No matter how you start it, you would end up with 2 times itself 5 times. 48. What can we multiply to get that? Jordan?
6 and 8.
6 and 8. I was thinking 12 and 4. Okay. Doesn't matter as long as it actually gives you 48. 2 and 24. Okay. It doesn't matter how you started as long as it actually gives you 48. Neither of those are prime. What can we multiply to get 6? Jordan,
2 and 3.
you're on a roll. Those are both prime, so we're done there. 8. Now, if you didn't really want to think much, where could you look to get your tree for 8? Right back over here where you had it for 32. And you can see it's 2 and 4 and then 2 and 2. Use what you already have to make it easier on you. So we'd have 2 and 4. 2 is prime. 2 and 2. Those are both prime. So your prime factorization for 48, you have 4 2's. So 2 times 2 times 2 times 2. Then you have a 3. That's what we did on Tuesday. Then, to find the greatest common factor, we're just looking at the pairs of numbers. So we have 4 pairs of 2. Now, here is where sometimes we get confused. This is not 2 times 4. Is not. This is 2 times 2, which gives us what, everyone? 4 times 2. 8 times 2. So your greatest common factor is 16 because you're taking 2 times 2 times 2 times 2. You multiply the pairs by each other. 2 times 2 times 2 times 2 to get a total of 16. Now, you do not have to write this down, but I just want to show you kind of a comparison to this method compared to probably the way you were taught in elementary school, which is fine because that's typically how it's taught first. So, more than likely, what you were told to do was to take both the numbers you're wanting the greatest common factor of and list all the factors, which is possible. But I'll tell you, it is much easier to make a factor tree than to think of all the factors of a number, especially when they get to be bigger numbers. Okay? So then you have to realize you could do 1 and 32, 2 and 16. See, and I'm glad I did this before because now I just look at my sheet from before. And then 4 and 8. You have to be able to remember all those factors. Where here, you're just breaking down small numbers. Okay? Then you have to think of all the factors of 48. 1 and 48. 2 and 24. 3 and 16. 4 and 12, I believe. Yes. And then 6 and 8. Okay? Now, I went through them pretty quickly because, like I said, I did this like 2 hours ago. If you were trying to come up with all of these, it takes a while. Then you can easily see the biggest number in both lists is 16. I promise factor trees and prime factorization is much quicker. You are more likely to forget a factor when you're listing them like this than you are to forget something when you're breaking down a small number. Okay? I always try to show you the easiest way to accomplish something. All right, I'm going to give you one to try to figure out on your own, and then we'll go over it. So if you have to find the greatest common factor for, did I do that? No, I didn't. 18 and 30. So you're going to come up with your factor tree for 18, your factor tree for 30, write your prime factorization, and then figure out your greatest common factor. And then we will go over it. Look at your examples if you need to. All right, what can we multiply to get 18? There's a few things, so your tree may not be exactly the same, but your prime factorization will be. John, perfect. You could have done 6 and 3. It will still end up the same, okay? 2 is prime. What do we got to do with 9, John? 3 and 3. And those are both prime. So your prime factorization for 18 is 2 times 3 times 3. Whether you started with 9 and 2 or 6 and 3. Doesn't matter. Okay? 30. Someone else. How are we breaking this up? Mason?
10 and 3.
10 and 3. You could have done 6 and 5. You could have done 2 and 15. Doesn't matter. Okay? 3 is prime. So 10, Mason?
5 and 2.
5 and 2, 2 and 5. Doesn't make a difference. Those are both prime. So our prime factorization is 2 times 3 times 5. Okay? That's from Tuesday. Circle your pairs. You got a pair of 2s, a pair of 3s. So what is our greatest common factor for 18 and 30? What is the biggest number that will go into them? Mateo, how did you get that?
I just multiplied it by 2.
That's all you're supposed to do. Greatest common factor is 6 because you're taking your pair of 2s times your pair of 3s. To me, that is much easier than trying to think of all the factors of 18, all the factors of 30, making sure I get them all written down and figuring out which is the biggest in both lists. This takes us no time. It honestly is easier than making lists. Any questions? Okay, so those notes and those 3 examples are what you have to show me as you're walking out. What you are going to work on now is E8 in IXL. It is exactly finding greatest common factor. Now let me tell you this. You will not have to do a factor tree for every one of them. You may be able to look at 2 numbers and be like, oh, I know 6 is the biggest that goes into that. Okay? Or 5 is the biggest. But if you find you're not looking and getting it right, this will get you the right answer every single time. And it honestly doesn't take you very long. And I wouldn't do factor trees on my screen because when you go on, those factor trees disappear. Where if you write them on paper, if let's say the number 30 came up in a question 3 questions from now, you don't need to make a tree. You already know what it is. You've got the prime factorization already written down. Okay, you can use your screen if you want to, but you may be making the same tree for the same number over and over again because you didn't have it on paper to look at. Okay, you have more than enough time to get E8 done before you leave. I have already posted the grades for Tuesday's IXL, E3, E6, Wednesday's IXL, E4, E5, Tonight, I will post for E8. You could have possibly got 6 extra credit points this week. 2 on Tuesday, 2 on Wednesday, 2 today. Where typically you can only get 2 in a week. This week, you could have gotten 6. If your grade is not good for E3, E6 Tuesday, E4, E5 Wednesday, and you have raised them to 80 or above, if you show me your actual IXL screen with those raised scores, I will change it in Skyward. But my grades are due Tuesday morning. I am not taking late work. Okay? You get a 4-day weekend, so do I. So I'm not going through 500 emails Sunday night because you decided to do your work late. Any questions? All right. If your E8 is finished, you first need to see if there's anything you need to be doing for other classes. And then whatever you're doing, you just need to be quiet. Any questions? And I will go through and look who's done with E8 and who isn't. My screencastify always disappears on me.